Hey guys, welcome back. Today I'm going to talk about numerical pattern puzzles. I hope you'll have a pencil and a sheet of paper so that you can work on these. So there are some problems that you can try to solve in at least two different ways. The first problem is in a video game, which I know a lot of students like to play. We have these rules about points. So if you capture a large jewel, you get 7 points, and if you capture a small jewel, it's worth 3 points, and I want you to try to figure out what the largest score is that's impossible. Some of the scores that are possible are all the multiples of 3 because you can continue to capture small jewels, right? So you can keep on getting 3 and then 6, 9, etc. Also, the multiples of 7 will be scores that are possible, 7, 14, 21, etc. If you capture a small jewel and a large jewel, you get 7 plus 3, which gives you 10 points. So all the multiples of 10 are also possible. So the question is, what's the largest score that's impossible? The answer will be on the next slide, so if you haven't figured it out yet, I would suggest that you try it first before moving on, and just pause here. There are different ways of solving this problem, but the approach that I'm going to use is similar to the way I solved the problem with the weights, with the 255-pound weights. We're going to look at it inductively. So I'm going to write all the possible scores down that I can think of, and I have 3 is a possible score, 6 is a possible score, and I'm just listing these in chronologic order. 7 is possible with the large jewel, and then 9, 10, etc. Now, once I get 3 consecutive numbers that are possible, then I know that I can get all the subsequent consecutive numbers because I can always add just 3 to that first number, the second number, and the third number. So I know that I can get 12, I know that I can get 13, and I know I can get 14. 12 is 4 3s, 13 is the 7 plus 3 plus 3, which is 10 plus 3, and 14 is 2 times 7. So since I have 12, 13, and 14 all consecutively, that means if I add 3 onto 12, I'll be able to get 15, which is the next number after 14. Then if I add 3 onto 13, I can get 16, and if I get 14 plus 3, that gives me 17, and that means that I can continue on and always add 3 to each set of numbers, and I'll be able to get every other whole number value of points. So some of the impossible scores are 1, 2, 4, 5, 8, and 11. The question was asking for the largest impossible score, so the largest impossible score then is 11. Now let's move on to the next puzzle. This I've seen a lot of people solve in many different ways. A printer uses 207 digits to number the pages of a book. How many pages are numbered in the book? This is an old-fashioned printer, so it's not like the LaserJet printers that we have now, but this is the typeset kind where you're using, so for 1 that requires 1 digit, for the page number 2 that requires 1 digit, for the page number 10 that requires 2 digits, the 1 and the 0. For the page number 100, that uses 3 digits, the 1, 0, and 0. So the digits that are used are 207 digits. The question is, how many pages are in the book? Again, you can pause here to try to solve this problem on your own, and then I'll have a sample solution on the next page. I've seen people organize the page numbers in different ways, but for me, it just really helps to look at a table. A lot of people have mistakes with counting the number of pages. The number of pages between, like, let's say 1 and 9, there are actually 9 pages, and then between 10 to 19, there are actually 10 pages. It's basically the numbers from 0 to 9. If you look at the ones place, there are 10 numbers from 0 to 9. Okay, so I'm organizing my chart as I'm keeping track of the number of digits used on the far right column. And my total sum at the very, very end of the right column should be 207, because that's what was given in the problem. Now, between 1 through 9, I have 1 digit per page. There are 9 pages, so I've used 9 digits for those 9 pages between 1 through 9. Then between 10 through 19, I'm using 2 digits because, you know, the 10 uses the 1 and the 0 digit, 19 uses the 1 and the 9 digit, and there are 10 such pages, and so there are 20 digits used. That's 2 times 10. Similarly, between all the way until 90 through 99, I'm also using 20 digits to number those pages, but then the tricky part gets to the part where I have 3 digits being used. So if I sum up all of the numbers, the 9 for the digits used, the 20, 20, 20, 20, 20, 20, 20, 20, 20, and then I subtract that from 207, then I get 18. So I know I can use 18 digits for the page numbers 100 through something, and I can't figure out what that something is. That's the question that's being asked. Well, if there are 3 digits being used per page in the 100 plus page numbers, and I can use 18 digits since I have 18 left, then it's 18 divided by 3, that gives me 6 pages. And some students get up to that part, but then I've seen people not be able to count correctly up to how many. So if there are 6 pages, it's 100, 101, 102, 103, 104, and 105 is the 6th page. It's kind of counterintuitive because it's not 106, but because of the 0, that gives you 1 less than 6, so it's 105, so the answer is 105 pages. This was a little tricky. Now the next problem is about jelly beans. And you can set this in any kind of context if you want, but this is a nice little context. So a jar is full of jelly beans. If you count them by 2s, 3s, or 5s, there's always 1 jelly bean left over. If you count the jelly beans by 7s, there will be none left. How many jelly beans are there in the jar? So here's a hint. So if you count them by 2s and there's 1 jelly bean left over, then that means that the number of jelly beans is going to be an odd number, right? So, for instance, if you had 9 and you divided by 2, you're going to have a remainder of 1. But you know it can't be 9 because if you count by 3s, there's going to be 1 jelly bean left over as well. So it's not going to be 10 either, because if you divide by 2, there's not 1 left over. Even though 10 divided by 3, there's a remainder of 1. If you count by 5s, there's 1 jelly bean left over as well. So you know it's not going to be ending in 0 or 5. So you can eliminate possibilities from there. Also, it says if you count the jelly beans by 7s, there will be none left. So that means that the number of jelly beans is going to be a multiple of 7. I want you to try to solve this problem, and we'll go over different possible solutions that you guys had in class, at the beginning of class. In addition to solving this problem, I'd like you to come up with another problem. If possible, I'd like you to email that to me, and then I'll put that on a PowerPoint slide, and we can complete everybody's problems also at the beginning of class. I want you to come up with a problem that sort of gets at the same ideas as at least one of these 3 numerical pattern puzzles. You can make it easier or harder, just to make it kind of interesting and possibly something that you could give to your students once school starts again. Or, you know, something that is along the lines of these problems and is in a context that you like or that you think that your students will like. Okay? So I'll stop it here, and hopefully you'll get some solutions for this problem number 3. We'll share those, and then we'll go over the problems that you create. All right? See ya.